Good morning, students. Welcome to SRPS Online Studies. Today, we are going to start our chapter number 11 of class 8, that is force and pressure. So, we have to know in this chapter about so many that what do you mean by force and what do you mean by pressure. Yes. Now the next one is first question is our what is force? So as for this we have seen so many examples at our home also. How many times we have pushing or pull something every day at our home, and when we open a drawer we are pulling, when we close something a drawer that it means that we are pushing. See in this picture what you have seen, what is force? The definition of force is now that force is the push or pull of on an object. See, in this picture, we have seen so many push and pull things. Example: if an object has to be moved from its place, it has to move from its place by pushing or pulling something. Okay, see the man is pushing a car, this man is pulling that cart, the horse is that pulling that this one, the football man is then pushing a football. So this type of example is of push or pull. So what is exactly a force? Force is the push or pull on an object. It means that when at our home, when we are closing the door, we are closing the drawer, then we are pushing it. If we open the drawer, it means that we are pulling it. Understand? Lifting your school bag, that is pulling. Okay. Now, pushes and pulls are force, we know about it. So that is the main thing. Now, the next one is force applied by. Second one is how the forces are happen, how the force are applied. Second one is our topic is forces are due to interaction. Interaction. What is the meaning of interaction? Interaction means to be how they interact, how they close with each other. So an interaction of an object on one another object results in a force between the two objects. Okay. So how we can see with the help of example. Example, if a man stands behind a car, okay, the car does not move. See, if the man stand without any movement or without any pushing or pulling to the car, stand quietly, it means that the car does not move. If he pushes the car, which you see in this picture, if he pushes the car, he applies forces and the car begins to move in the direction of the applied force. Again you understand, this one is our car and the one man is pushing from behind it. So what happened? At first that the car is in the stationary position, is in the rest position, or when we are pushing this car, it means that it has to be moved from its position. So what happened? So the car begins to move in the same direction in which they applied force. Okay, understand it? So the second one topic is forces are due to interaction. If we are close to the surface, if we are in contact with the any object, so that in that case the forces are applied. Now the third one topic is our resultant or net force. Resultant or net force. So what happened in this one? So we can say that when forces are applied on an object in the same direction. Understand? If the forces are applied to a body or anything in the same direction, so what they do, they add up. Add up means that the net force or the resultant force in the same direction is a single force. Is a single force whose magnitude is the sum of the two forces. Let us understand. These are known as our exploring forces also. So understand with the first example. If two forces act on a body in the same direction, let's see at the first picture, what happened? F1 force and F2 force is applied to the object on the same direction. So what is their net force? Their net force is the sum of the two forces. It means that if the two forces are applied to a body in the same direction, so what we are doing? What is their net force? Net force is equals to F1 plus F2. Understand? It means that these two forces are add up. Now the second one is the second case. What happened in the second case? If two forces act on a body in opposite direction. Understand? If two forces act on a body in opposite direction. So what happened? So the net force is the difference between the two forces. See in the picture, one F1 force is applied to the object from the left direction, and F2 force is applied to the object from the right hand part. So what is their net force? Net force equals to F2 minus F1. It means that is, it makes a difference between both of the forces. So the effect of the forces, effect on the object depends on the net force acting on it. Understand? It means that effect on the object, that your object, how much force is applied to your object, is all depends upon the net force which is acting on the object. Okay. Now what are the forces, what are the effects of forces, or what can force do, we can say. So in this topic we are going to discuss about that what are the forces effects has to be happen on the object. So our first effect of force is force can make an object to move from the rest. See in the first condition, a man is pushing the car. So at first this car is in the the rest position. After that, after giving him some force, after giving it some force, what happened? We can see that by this pushing part, what happened? This car began to move. So this one. So by this example, we understand that force can make an object to move from the rest. It means that if something object is in the rest position, and if we are applying some force to them, so what happened? That object is begin to move. So that is our first effect of force. Now the second one is force can stop a moving object. See the ball, the football or goalkeeper has to be stop the football from going into the goal. So what happened? It can apply some of the force. So force can stop a moving object also. Or have you seen in the case of cricket also? So the batsman hit the ball, and what they do, the bowler or the fielders can be stop the ball by using their force. Okay. Now the third effect of force is force can change the speed of an object if it is moving. See in the third case, the boy is riding a bicycle. So what happened? It is giving some force to the pedal. So because of this force to the pedal, this bicycle is moving. Okay. So that is we can say the third effect is that the force can change the speed of an object if it is moving. So the boy is giving a force to the pedal and the bicycle is moving. Fourth one effect is force can change the direction of a motion of an object. Direction of a motion of an object. So we can see in the case of cricket also. So what happened? We have seen in the cricket, the batsman is hitting a ball. So what happened? So the ball is coming in this direction, from the straight direction, and when the batsman hit the ball, so the ball is going in anywhere condition, in any very direction. So we can say the force can change the direction of motion. So the batsman hit the ball, so ball is going in any of the direction. Fifth one is force can change the shape of an object, or force may cause one or more of this effect. Okay. So we can say if we are applying in the case of dough, we can see at our home also when we are preparing a chapati, what we are seeing, we are applying a force to the roll, and when we are applying a force to the roll, what happened? It happened that it can change the shape, it can make in a roll form. Okay. So these are our effects of force on an object. So we can say that first force can make an object to move from the rest. It can stop the moving object. Force can change the speed of an object. Force can change the direction of a motion. Force can change the shape of an object. Okay. Force may causes one or more of these type of effects. Now the next one is the types of forces. When we are talking about the types of forces, so we have seen that there are two main types of forces are there. Which two types of forces? They are contact forces and non-contact forces. Contact, what is the meaning of this contact word? Have you ever heard this word? Yes, contact means getting close to each other, getting in contact to each other. So contact force first. Contact forces are forces exerted by one object on another when they are in contact with each other. It means that this type of forces is applied only when the two things are one object and one of them that is pushing when they are in contact with each other. So this type of forces are known as our contact forces. So have you understand what is contact force? Or we can say that when any of the body are in contact with any of the body, they are known as our contact forces. Okay, so in that contact forces, two types of forces are there. Contact forces are of two types. Which are they? Muscular force and the force of friction. Okay, now the next one is what do you mean by the muscular force? Muscular word, which word is there? Muscles. It means that we can say that the force which is exerted by the muscles of our body. Understand? The force which is exerted by the muscles of our body, that is called our muscular force. We can take one example of horse. A horse uses their muscular force to pull the cart, pull a cart, or we can say our blood gets pushed into our arteries by the muscular force exerted by our heart. Okay, so that is our muscular force. When what is our frictional force or the force of friction? What is that? See, force of friction, it means that what is friction? Friction is a force that slows things down or prevents thing from moving or opposes the motion. That is our friction. So what happened in this case, in this frictional force? So from we can say that one surface moves or tries to move one another surface, the force of friction starts acting on the surface. Okay, it always opposes the motion. So we can take the example also. Okay, the tires of a bicycle and the road. Have you seen the tires of your bicycle and the road? That is also one example of frictional force. And between the block of wood and the floor, when we are pulling a block of wood from the floor, this type of frictional forces happen. So it means that what is friction? Friction always opposes motion. It means that two examples we have taken here. One, when you are riding your bicycle, on the road, what happened? Road have some friction over it that opposes your motion. So that type of motion is called our frictional force. Now the next one is our non-contact forces. What are the non-contact forces? Non-word is coming there. It means that in this type of contact forces, not a main thing that you have in contact with the object. So non-contact forces are forces exerted by one object on another without any contact with each other. Understand? Without any contact. If the force is applied, that is called our non-contact forces. Non-contact forces are our three types. What are they? Magnetic force, electrostatic force and gravitational force. Okay, so first of all we are going to discuss about the magnetic force. Okay, we have seen so many times the magnets examples also. Okay, have you seen that a large magnet is being used to pick out scraps of iron from the garbage? Have you seen that? Yes. Now we are going to discuss about non-contact forces. So what you have seen in the non-contact forces? The non-contact forces are forces exerted by one object on another without any contact with each other. Okay, so now when we are talking about the non-contact forces, we can see that the non-contact forces are of three types. Which are they? First one is magnetic, second one is electrostatic, and the third one is gravitational force. So, when we are talking about the magnetic force, the force which is applied by magnet, we can say what is the definition of magnetic force. We can say that the force which is exerted by a magnet, that is called our magnetic force. So, what is the example we have seen? Electrostatic things, or we have seen so many. A large magnet is being used to pick out the scraps from the pick out the scraps of iron from the garbage. So it is using force to it is a using force to lift the iron pieces. So this type of forces is known as our magnetic force. Or we can see one more example we have seen at our home also. What? Put some iron nails on a sheet of paper and bring a small magnet near these iron nails. What happened? So we will see that the iron nails are pulled up towards the magnet even when they are not in contact with them. So what this shows? This shows that the magnetic force can act from a distance. So we can say that the force which is exerted by a magnet, that is called our magnetic force. Okay. So now the second one is our electrostatic force. What is electrostatic force? We can say that it is another kind of non-contact force. And what we have seen to the electrostatic force, we can say by the help of an example. Okay. Students, have you seen when the comb is rubbed in, when you are comb your hair, rubbed your comb to your hair, so it requires a property of electrostatic charge. Okay. So and the electrostatic charge is of two types, that either it is positive or negative. Electrostatic charge can exert a force. Okay. And what you have seen in the case of comb and bits of paper, so what you have done at your home, take a paper, make a bits of paper and rub the comb in your hair, and then you take in contact, near contact with that bits of paper. What happens? You have seen that all the bits of paper is moved towards the comb. So what is that? That is our electrostatic force. So what we have seen? So electrostatic charge can exert a force. So that force is called our electrostatic force. Okay, understand? Now the third one is our gravitational force. What is gravitational force? Now let's understand. Gravitational force is the force with which the earth pulls everything towards itself. Have you seen gravitation? Have you heard of the gravitation word? What happened? So what is gravitational force? Gravitational force is the force in which what happened? The earth pulls everything towards it. Okay, so that force is called our gravitational force. We can take an example of a ball. When we throw a ball over it or up, what happened? It slows down and then falls down towards the earth because of gravitational force. Understand the types of forces, contact force and non-contact forces. Okay, now first one, muscular force. We have understand it. Muscular force is the force exerted by the muscles of our body. We use muscles force for various type of activities. So in this part, see, so many examples are there. They had given so many pictures of muscular force. What happened? Animals like bullocks, horses, camels, donkeys, elephants also uses their muscular force to perform various tasks. It means that if we are riding a bicycle, if this girl is riding a bicycle, it means it is also acting some force over on the pedals. If this girl is jumping this rope, it means that it is applied some forces. Or the next thing, when the bullocks is there, when the horse is there, what happened? It also having some push. Okay, it also have pulling something. What it means? It means that everything around them. So everything which every object which applied their muscles force to move an object, that is called our muscular force. Force of friction, same thing. Force of friction is also the same force which opposes the motion of an object over a surface. So we can say, what is an example? A ball rolling on ground gradually slows down and comes to the rest due to the force of friction. If we stop paddling a bicycle, it gradually slows down and comes to a stop due to the force of friction. Understand? So that is our force of friction. Now non-contact forces, magnetic force is the force exerted by the magnets, we can see. Now the example is force of attraction. Example of force of attraction and repulsion between two magnets, force exerted by a magnet on a piece of iron or steel. Let's see what is there. We have seen a bar magnet have two poles, one is north and the second one is south. So in the A case, you see, when we bought one bar magnet, north pole is in contact, is in bit contact or a bit or close to south pole. What happened? Two opposite poles are coming in contact with each other. So what happened? It attract each other. Okay. Now in the second case, same thing, same opposite poles are there of the bar magnet. What happened? They attract each other. So in the C case, what happened? Let's see. Bar magnet first A north pole and the second bar magnet north pole, same poles are coming in contact with each other. So what happened? They repulse each other. In the fourth, that is also the same thing, bar magnet is there, south pole is there, and the other bar magnet south pole is there, same poles are there. So what happened? The same poles are there, what they do? They repulse each other. So by this activities or by these things, we have to know about that these are our due to magnetic force. In the second case, we have already discussed about them, that we have, when we put some iron nails on a table and then we take a bar magnet near to them, what happened? All the nails are getting upwards and stuck to the bar magnet. Okay, so this one is our magnetic force. Now the electrostatic force. Electrostatic force is the force exerted by a charged body on another charged or uncharged body. Example we have taken a plastic straw charged by rubbing with paper, okay, attracts a suspended plastic straw. Attract him. So in the first case, what happened? A plastic straw is there, it is charged by rubbing with any type of thing. Here we are rubbing with paper. So what they do? It attracts suspended plastic straw. In the second case, a plastic straw charged by rubbing with paper repels a suspended plastic charge by rubbing with paper. Same charges are coming in contact with each other. So what they do? They repulse each other. Okay. So that is our electrostatic force. Now the third one is our gravitational force. What is gravitational force? That the force which is exerted by the earth on all objects. Because of that reason, all the objects have to be comes towards the earth. What is the examples? See, so many pictures are given for the gravitational force to understand the gravitational force. What is there? First one, a coin or pen falls down when it slips off your hand. Understand? A ball thrown upward falls down. Okay? Leaves and fruits fall to the ground when they get detached from the plant. Okay? Water in rivers flow downwards. So why these all things are coming towards the downward? Because of the gravitational force. Okay? Now our next part of this chapter is there, that is pressure. What is pressure? So we can say pressure is the force. What is pressure? We can say that pressure is the force acting on a unit area of a surface. Unit area of a surface, it means that pressure, when we are not talking about the pressure formula, that the pressure is equals to force upon area. So by this formula also we can find out the definition. What is the definition? On a particular area, whatever the force are acting to on it, that is called our pressure. It means that we can say that what are the things, if the area is smaller, the pressure is more. Understand? And that is most important thing, you have to keep it in your mind. These two notes are there. If the area is smaller, the pressure is more, and if the area is broad or larger, so what happened? The pressure is low. Understand? These two concepts you have to keep it in your mind. That is most important things. Okay, so it is easier if the area is smaller, the pressure is more on the surface for the same force. So we can take so many examples. Here you have seen so many examples are given there, so many pictures are given there of the force. First one, example, it is easier to push a nail into a wooden plank by its pointed end than its head. Okay, have you seen in the first case? See, iron nail is there. So iron nail have two ends, one end is broad and the other one is very pointed. So what happened? Which one is easier to be go into the wood block? Obviously the which one is the sharp or which one is the pointed, and that is easiest go into the wooden plank. Okay, it is easier to cut vegetables with a sharp knife than a blunt knife because the pressure is more. Understand? This one is also one of the reason. The next thing is the shoulder. What happened to your shoulder bags have broad strips and not a thin strips to reduce pressure. Have you seen your school bag? Your school bag have also have a broad shoulder strips, okay, to reduce the pressure. Okay, so one more example we have seen at our home. You sharp your pencil at your one hand. Okay, hold it between the index fingers of both our hands and press it from both sides. You have taken one pencil, you have sharp it and you have taken from the index fingers by the two ends, you press it. On which finger do you feel pain? Which one is pointed? Okay, so which one is pointed? That in that index finger we are feeling some of pain. So that is a reason that if the area is small, if the area of contact is small, in that case the pressure is more. Okay, understand it? Pressure exerted by liquid gases. We have seen in this chapter that pressure is exerted by liquid gases also. Okay, so what we have seen in that part? By liquids we have seen so many examples and so many activities we have done in our previous classes also because of that. So what are the main thing here? We have also given one activity. What is that activity? Liquids exert pressure on the walls of a container. On the walls of a container, what you have seen in this one? Liquid exert pressure on the bottom of a container. It depends upon the height of a liquid. First of all, we have to understand this activity, that exactly what this activity is there. Here you have seen two activities are given in the one. See what is there? Two activities are there. We can say that take a white glass tube, open at one end. Okay, tie a rubber balloon to its lower end. Pour some water into a tube. So we will notice that the balloon bulges downwards. Okay, so this shows that the liquid exert pressure on the base of the container in which they are kept. Understand? Now in the second case, what happened? In the second case, now take a vessel with a tap like opening at its side. Okay, so tie a balloon to the opening and fill the vessel with water. Then we will notice that the balloon bulges outwards. Okay, so what happened? This shows that the liquid exert pressure not only on the base of the container, it means that it exert pressure also on the sideways of the container. So this one is our one activity. Second activity is these two of right hand side, these two activities is of one another activity. As for this activity, what we are doing? We take a plastic container. Okay, we take a plastic container and make 4 holes in it at different heights, or we can say that at different levels. Fill the container with water and let water keep flowing into it from a tap. Then what happened? The force, and now notice the force with which water comes out from the holes. Okay, so what we will find? We will find that water comes out with a greater force from the holes at a greater depth. What do you mean that it's right? Water from the bottom most hole, from what we can say that the water which comes out from the bottommost hole will be spurted out the farthest one from the container. So it means that what this shows? This shows that the pressure in a liquid increases with increasing depth. Okay, so these are the main points which comes out from these activities are: liquid exert pressure on the bottom of a container. It depends upon the height of a liquid column, how much height of that liquid is. Liquid exert sideways pressure also. By these two activities, 3 activities, we get it to know about them. Liquid exert equal pressure at the same height. Okay, so this one is our two or three activities which we have discussed in this liquid gases. Now pressure exerted by gases also. Pressure exerted by gases. So we can see in this case gases exert pressure on the walls of a container. Here you have given so many examples of this content. So in the first one, tube of bicycle or anything is there. Let's see, when we are pumping air into it, so what happened, that the air which goes into that tube, it had exert some of the pressure to the walls of that tube. When we are inflated that balloon, what happened, the air which goes into the balloon, it exerted some of the pressure onto the walls of a balloon. Same in the case of bump and square. Same in the case of this this one which we are using in the swimming. So in this case also we are going to know about them, that the pressure exerted by gases also. Okay. So we can say that in this chapter we are going we had already discussed about most of the factors, that force and pressure, that what is force. After that we are going to discuss about what are the effects of force, in which direction the force force is adding and which one is force is reducing, or in the second part, types of forces, then how many types of contact forces are there, how many types of non-contact forces are there. We have seen that. After that we have seen the pressure, what mean by the pressure, and so many examples we have seen in the case of pressure. Then after liquid, pressure is applied on the liquid also, pressure is applied on to the gases also. So in this chapter we had already discussed about force and pressure. I hope that you understand each and every content very well. Thank you.